Hello, everyone. My name is Alex. I'm very glad to have you here with me today. In today's session, we're going to take a quick overview in a machine learning algorithm. Specifically, we're going to take a look into a one that is classified as a supervised learning one, um, which, as you may know, the supervised learning algorithms in machine learning are those that work with data that is already labeled, so we don't have to deal with that part, at least not by now. So yeah, the title goes as optimal feature selection for classification with random forest. Well, we're gonna get into this right now, but before I want to tell you that we're gonna use a dataset which is about diabetes. So yeah, we have right here our dataset which has different characteristics of like I don't know, maybe a medical study that was made, I don't know where, but yeah, it has different like characteristics of a patient that may have or may not have diabetes in the study. So as you can see, right now we have like pregnancies, lookouts, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. And of course, the outcome. The outcome is basically if the diagnostic is positive or is negative. One for positive and zero for negative. So, okay, let's don't stay a lot with this one. The code we're going to use right now is right here. So I'm going to share it with you so you can see basically how it works. Let's try to get it a bit quickly. But anyway, if you have any kind of question or any doubt about the program, the code, or like the concept in general, I'll be glad to solve it if you write it down in the chat. So yeah, guys, write it down in the chart, in the chat, and I'm gonna check it at the end of the explanation. So yeah, we're gonna work with the skitlearn library, which gives us already the random forest classifier, the training split function, the recursive feature elimination function. Also, we're going to use pandas for the managing of the CSV comma separated values file, which is well, the diabetes CSV that we're working with, which is this one. And yeah, that's it. So how does it works? Basically, we're going to work with the diabetes program in order that we can, in first place, like split our data. We're going to separate our outcome from the rest of the data so we can uh, get to know which data is the one that we're training and which one is the outcome. Then what are we doing right here? I just create our random forest classifier object which we're going to save right here in the model a variable, and that's it. Here we have the random state, which is we're going to state it in 42. If you don't know what this is, I will be glad to explain you at the end of the video because it may take me a while and I don't want to exceed the 10 minutes limit that um, the manager told me to keep in. So okay, let's keep it that way. It's just like a random seed. And then we're going to split the data set into four variables, which goes by xtrain, xtest, and the in the axis y, the y train and the y test. So yeah, once we have created our test split in different variables, we're gonna start working with those. So here goes the actually important part of our code, which goes as with a for cycle, which starts in two, which means that we're gonna start working um, to get to know which number of characteristics and what characteristics are the ones that works the best to get a prediction of the diagnostic of of the patients, right? So this works very simple. It starts to work with only two of the eight variables we have right here. So it tests in order that says like, okay, I want to work with just these two variables. Am I able to predict the outcome of the diagnosis just with the variables? No, I'm not. Okay, let's get into consideration that to do this, we are going to use the metric of frog-awk. So it evaluates the results of the model prediction by using this metric. But, all right, let's give it a minute to get into it. So yeah, it goes the iteration of the variables like this gets two, and it goes like, okay, the metric of the evaluation of the prediction with those two variables is very bad. So we're going to take three, and it gets three and says like, okay, it's better but it's not enough. okay, I mean now take 4, and even though if we take like we're in the seventh iteration, it also like discriminates if out of those 7 variables that is taken in the actual consideration, maybe the insulin is actually not working. So it may say like, okay, we're working with seventh, but guess what? The insulin variable is not working for us. So we're gonna put that apart and just work with the rest of variables that are right here, and that is gonna be done by the line of code that is right here. So yeah, as I was telling you, it creates the recursive feature elimination. Then after that we have the features elimination. We're gonna um, do this function, which is the important one that I just told you. This one is makes an array of Boolean values, which is going to tell you which variables are actually effective to train your model, and which ones are actually like not working so well. So you can take that in consideration. So yeah, once you know which one are useful, you create a new data frame with only your selected features. Basically, when you already have those, you repeat the process. You split data, you train a model and make your predictions, and calculate which ones are actually working for you and which ones are not. So that's it. At the end, you gotta save data for plotting, which is going to happen just right here with the matplotlib. And which is important to tell is that once you have like you're out of the for cycle, you're going to get to know which were your like the winner um, variables or characteristics. And once you know them, you can finally do like your final training and prediction, which is going to be like the best you can get in with those data, right? So yeah, right here you make your predictions after training it and splitting the data. And of course, you need to calculate the performance metrics to know if it's actually good or it's actually not. If you get a value above 5, it's good, but if you get less than 6, I would say like it's not that good, and you maybe should check your process, or maybe try to change your data set or something like that. So yeah, then you have the confusion matrix, which I'm gonna show you like real quick, like what this is about. It's like showing the true positives, true negatives, false positive, and false negative of your predictive function or model. So yeah, let's try to run this right here. Let me see if I'm able to do this. Okay, let's try to it. There you go. Let me make this a bit bigger so you can see. There you go. And I'm gonna run it in my diabetes file, which is a CSV values, I mean, comma separated value. Yeah. So yeah, here we have the results. This graphic shows us that the best number of characteristics for our model was 5, because 5 had a rock score of almost .76 rock which is it's pretty good. It actually can predict some diagnostics, which is pretty good. I mean, very good notices for our model. So yeah, we're gonna get now to the confusion matrix. So yeah, as I told you right here, um, we have our confusion matrix, and the values were the following. The true positive were 80, the true negatives were 39, which is pretty good, taking in consideration that just the mistakes we made right here were the false positives and the false negatives, but they are like not a lot. Like it's only 19 and 16 out of the 80 true positives and the 39 true negatives. So yeah, that's all for this algorithm, guys. If you have any doubt, please leave it in the comment section and let's check them and solve your doubts.